Okay, so what did I say yesterday? Well, I gave you guys 3 different ways to graph these curves, okay? 3, Pam. I said that you can graph them with the calculator, correct? I said that you can graph them using the midline and the amplitude. I said that you can graph them as a 3-step process by graphing the original one, changing the amplitude, and then shifting it, okay? But what if I don't want to do any of that? What if I just want to answer a question about one of these? And in this case, I want to answer the question about the range. Now, what is range? Lowest to highest, right? So if this is my curve, do I really have to go through the whole process of graphing it to answer this question? I sure hope not. Let's just pretend it said sine. If it just said sine, what would be the range? Just sine. What's the lowest? -1. What's the highest? 1. Okay. Well, what happens if I throw the 7 in front? What does that change? Give me a word. Starts with an A. Amplitude. So that changes the amplitude, otherwise known as the vertical stretch, right? So if I vertically stretch it by a factor of 7, what becomes the lowest point? -7. What becomes the highest point? 7. And then what am I going to do? Then I'm going to take that curve and I'm going to shift it up 4, right? I'm going to shift it up 4, which means what's going to happen? The low point's going to go up 4 and the high point's going to go up 4, correct? So what's -7 plus 4? -3. And what's 7 plus 4? 11. Okay? And so this would be our range. All right, this one. If I just had cosine of x, what would be the range? Lowest point would be -1. Highest point would be +1. Dylan, don't let this mess you up, okay? I put a -5 in front, right? Talk to me about what the negative sign does. The negative sign takes my curve and reflects it. So the highest point is still -1. The lowest point, the lowest point is still -1. The highest point is still +1, right? And then it gets what? Then the amplitude gets changed, right? By 5. So what's the low point? -5. What's the high point? 5. Yeah, so that negative sign reflects the curve, but it does not affect the range, does it? Okay. And then the +2. All right. Add 2 to the -5. Add 2 to the +5. And there you have it. Is that cool? All right. All right. Sine, ready? Just regular sine. Okay. Still -1 to 1, right? The 25 makes it 25 times taller in a sense, right? Or stretched. And then the adding 35 means I do what? Add 35 to the -25, add 35 to the 25, and there you have it. Is that all right, guys? Cool. I want to work backwards now. I want to take this picture and I want to see if I can find the equation. Okay? So let's check out something about this. Give me a piece of information that might be interesting to know about this picture if I want to try to write the equation. What do you guys think? What is something that you might want to know? Say again? I still didn't hear you. The range, yeah. Yeah, okay, so what's the range? What'd you say, -2 to 6? Okay, but say it from least to greatest, right? We always want to go, yeah, we always want to go that route. All right, I agree with that, no doubt. All right, so that's good to know. How's that going to help me get my equation, though? I agree. I think that is going to help me, but my question is how? How's that going to help me? Give me something. Give me something. We got to problem solve. We got to try to figure this out. I could just tell you, but what fun would that be? Let's see if we can figure it out. Let's see if we can figure it out. What else might be interesting to know about this curve besides the range? Midline. How do I find that midline? You're right. That midline, it would be like right here, right? How do I find that? What is that? What is that? Come on, I have almost 30 highly sophisticated brains in this room. Highly sophisticated. Yes. If I got a low point of 6 and a high point of 22, where's my midline? Somewhere in the middle. 14. Yeah. How'd you get 14? 22 plus 6 is 28, right? Half of 28 is 14. So he averaged them together. Yeah, of course, right? He averaged them together. All right, so why is that important? Why would I want the midline? Why would I want the midline? Well, I agree. That is definitely important. It gives me the C value, right? It tells me how much I shifted, correct? So it looks like I shifted up 14 units. All right. Well, what else do I need to write the equation? I know it's a sine curve because it told me it was, right? So what else do I need? What else do I need? I need the A value, right? So what does the A value represent? The amplitude. Can I figure out the amplitude? Zach, can you tell me what the amplitude of this is? If the midline is at 14 and the highest point is at 22 and the lowest point is at 6. Yeah, what is it? What, Zach, what does the amplitude represent? Yeah. So how much of that did I do? What are you trying to figure out? Yeah, so what two numbers are you looking at? 22 to 6, so we know that. What is it? You're adding them? Is that what you're doing? Or are you subtracting them? You're subtracting them. 20, so why are you subtracting them? Okay. Well, we did that already. It's 14. So how far is it from 14 to 22? Yeah, how far is it from 14 to 6? So that must be the amplitude, right? I must have went 8 up. I must have went 8 down, right? Boom. All right. So, yeah, I mean, guys, I wanted to really sort of like pull that out of you, and it was like literally like pulling teeth. But it's funny because my son, like my older son now, has he's losing like his last teeth, you know, but he's got one that's like stubborn, and he's like it's basically falling out, you know, and he's like this morning he wakes me up at like 5:15, Dad. I'm like, what? He's like, can we do the dental floss and door thing? I'm like, really? He's like, I got to get this tooth out. I'm like, all right, we'll do it this weekend. Yeah, he wanted to wait till the weekend. He said he has to be ready for it. Ooh. We're going to start looking at changes in frequency. All right, so on the grid below, we have a cosine curve. How many cycles do you see? How many cycles of cosine do you see? 2. Yeah, I got one cycle. I got a cycle here. I got a cycle here. Okay. Talk to me about some special features. Was this graph shifted up or down at all? I'm seeing a lot of people shaking their head no. I agree. Okay. This number right here represented the amplitude, and does that make sense? From the middle, did I go up 3? Yeah. Did I go down 3? Yeah. Okay. So everything's looking good. This matches up nicely. Here's what I want to do. I want to take a measurement. I want to measure how long it takes for one cycle. Okay? So I have 2 examples here, right? So off to the side, what I'm going to do is this. I'm going to take the absolute value of negative 2 pi minus 0. What did I do right there, guys? Well, do you guys agree that this point right here is where the first cycle begins? Yes? Do you agree that this is where the first cycle ends? So if I want to know how long that is, what do? I take one point and subtract the other, don't I? Now, if I said how long, so I'm going to change the phrase now. If I said what is the difference between these, I could get a negative, right? If I said what is the space between this, well, the space between has to be a positive because I'm asking for a distance now, right? So what is negative 2 pi minus 0? Negative 2 pi, what is the absolute value of negative 2 pi? Positive 2 pi. All right. Now, what if I wanted to analyze the other cycle? Well, the other cycle begins here and ends here, right? So if I wanted to figure out how long this cycle takes, what would I do? I could either do one of 2 things, Zach. I could either do 0 minus 2 pi or 2 pi minus 0, right? Because I'm taking the absolute value, it doesn't matter which way I do it, okay? And what do I get in both of those cases? I get 2 pi, right? So what do you notice about the distance between those 2 cycles? They are the same, right? So the frequency is consistent, isn't it? Okay? We just calculated something really important. This is called, I'm going to have you guys write down a word. This is called the period. Okay? The period is 2 pi. All right, let's put some vocab words together now. How many cycles fit in 2 pi space? How many cycles did I get in 2 pi space? 1. Because each of these took how long to graph? 2 pi. Now, I had a couple people that were like, oh, there's 2 cycles. Well, guys, how far is it from here to here? 2 pi. How far is it from here to here? So how big is this graph horizontally? 4 pi space, right? 2 pi plus 2 pi. And how many cycles do I have? 2 cycles in 4 pi space, which means I get 1 cycle in 2 pi space. Seem reasonable? Okay, so I'm throwing a lot of different words out there, okay? Now, here's what we're gonna do. We're gonna start messing with this thing a little bit, okay? And we're gonna use the calculator to mess with this thing. Shay, are you ready? Okay. Shay, we are gonna mess with this thing so much. First thing I'm gonna do, I'm gonna get a window that looks just like this. And I'm gonna stay in radian form, okay? It doesn't matter which form we're in, but I'm gonna keep it in radian form. So I had 3 cosine of x. So if I'm working in radian form, guys, am I gonna add anything into the x or no? I'm gonna leave it the way it is, right? I'm gonna go to my menu. I'm gonna start at -2 pi because that's what? That's all the way to the left of my picture, correct? And I'm gonna go out to 2 pi. And if I hit enter, it should look exactly the way it looks on my paper with that curve, right? And does it? Fits perfectly, right? So this is an absolute representation of what my paper looks like. Cool. Now let's mess with it. What have we explored? Well, we've explored changing this number in front, right? Aiden, we've looked at what happens if this is negative. Yep. We looked if this was a bigger number or a smaller number. Yep. We looked at what happens if we add or subtract things to this, right? Okay, what have we not explored? Something in here, right? Yeah, we haven't looked at that yet, have we? Okay. So you're a curious kid, Aiden. Give me a number that you're curious about exploring. 2. Wow, what I mean, you are just what a creative guy. So let's throw a 2 on here. All right, let's see what changes. Okay. Let's see what changes. What happened? Give me a word. I got more cycles. Yes. Got it? All right. I got more cycles, didn't I? I wonder how many more I got. Well, let's see. Let's count them. 1, 2, 3, 4. So I went from 2 cycles to 4 cycles. So what did this number in here do? Did it double or did it add? We don't know, do we? It could have added 2, right? Or it could have doubled it. You're right. So again, this is, hey, we're exploring right now, right? You just made a conjecture, right? Saying it doubles, and I'm saying, well, maybe it didn't double, maybe it just added 2. So what can we do to explore this a little further? Use a different number. What do you want to use? You want to go to 7 right away? 4? Okay, we'll go to 4. I mean, we could go to 7, but then we got a lot of counting to do. You said 73. Okay, wow. Why? Let's throw an odd number in. 5. I didn't. I threw a 5 in. So based on the last results, ready? Based on the last problem, I'm either going to have 10 or I'm going to have 7 cycles, right? Because what happened last time? I either doubled it or I added 2, right? So let's see how many we have. 1, 2, 3, 4, 5. Okay, there you go, right? 5 over here, so probably 6, 7, 8, 9, 10. So what does this number do? It multiplies the number of cycles from the original 2 that we had, right? Okay. I'm not crazy about that concept of doubling. Okay. I want to show you guys another way to think about this for a minute. a way that's going to make it easier for you, Cam, okay? Here's what I'm going to do. Let's get rid of this 5 for a minute. Okay? Let's change our window for a minute. Let's change our window for a minute. Let's start our window at 0, and let's end our window at 2 pi. Okay? So in terms of our paper right now, guys, what am I looking at? I'm only looking at what? I'm only looking at the blue curve. Everybody okay with that? Okay. So here's my, guys, this is the creme de la creme. This is, if you take anything out of today, it's the next 4 minutes. Ready? Here it is. Here I have 3 cosine of x, right? How much space am I looking at horizontally? Starting at 0, ending at 2 pi, right? So I'm looking at 2 pi space. How many cycles do I see? 1. So with a regular cosine curve, how many cycles do I see in 2 pi space? 1. Okay? By the way, do you think it's going to change if I was to make this sign? Do you think I'm going to have all of a sudden like a whole bunch of crazy number of curves? No, if you had to guess, how many curves will I see? You think I'm going to see 2 curves now? Okay, let's see. How many do I see? What? How is that 2? A sine curve does what? A sine curve has to do what? Has to go up and then come back here, right? Yeah. So this is how many cycles? This is 1 cycle of sine, okay? So here's where it all comes together. If I throw a 2 here, based on what we saw a minute ago, how many curves should I see? I had 1, I should go to 2. Let's see if that happens. 1, 2. Did it? Sure did, right? Okay. Let's make sure that happens also for cosine. Let's make sure the same rule applies. Let's make sure the same rule applies. Two cycles, right? Starts here, there's 1, there's 2. So it works, right? Okay, so if I throw 5 in here, how many cycles should I see? 5. In what space? What's the space? Starts at 0, ends at 2 pi. So in 2 pi space, I now see 5 cycles. Okay? Here is a phrase. This number right here, this 5, whatever number is in here, is going to have a special name. Okay? Write this below in here, guys. I want you to write this in here. Somewhere down below. All right? Here's what we got. If I have the following function, let's look at this b value for a second. This b value is called the frequency. Now, what did that number adjust? The number of cycles. The frequency is the number of cycles in how much space? In 2 pi space, because that picture started at what? At 0 and went to 2 pi. The frequency is the number of cycles in 2 pi space. Okay? Now, the next thing you need to write down is the following. This is a definition. Actually, this might be on the next page. Let me just check. No, not really. It's sort of in here. I want to write it below. I like the way I do this better. All right, B. Period. Okay, ready? the word period, when we're referring to sine and cosine, is going to be the space required to graph one cycle. The space required to graph one cycle. How the heck am I going to figure that out? I'm going to figure out the space. Well, let me give you an example. Don't write this down. Okay, don't write this down. If I said that this is our example, cosine of 4x, right? Cosine of 4x. So here's, believe it or not, you've learned a ton in the last 4 minutes. Ready? Here's my graph. And we're looking at our calculator, starting at 0 and ending at 2 pi. Okay? Everybody agrees that that's what we did a minute ago, right? And we threw different numbers in this, right? And when we threw different numbers in this 4 gave me how many cycles from 0 to 2 pi? It gave me 4. It gave me 4 cycles. Okay? So it wound up looking something like this. 1, 2, 3, 4. Agreed? Okay. So I got 4 cycles from 0 to 2 pi. So how big was each cycle? How big was each cycle? Well, let me give you a different example, and then you tell me what the answer is now. Ready? What if I said this went from 0 to 20? If I said this went from 0 to 20, if you drew 4 cycles, how big was each cycle? 5 units, right? How'd you get it? You took 20 divided by 4, right? So if I told you that we're going from 0 to 2 pi, and I want to know how big each one is, what are you going to do? 2 pi divided by 4, right? You're going to take 2 pi, don't write this down, you're going to divide by 4, right? So how big was each cycle? If I reduce it, it would be pi over 2, right? Think about this for a minute. What's pi over 2? A half a pi, right? If you eat half a pie and another half a pie and another half a pie and another half a pie, how many pies did you eat? 2 pies. So you got 4 cycles in 2 pi space, right? Make sense? Okay. So let's go to this next page and we're going to answer these questions up here. 3 cosine of x. You should feel really, really happy about this problem because the only thing that's on this the only thing that's in this equation is the 3, right? That 3 changes the amplitude, doesn't it? What number is before the x? A 1. So how many cycles should I get in 2 pi space? 1. Which means if I only get 1 cycle, how big is the cycle? 2 pi. What's the frequency? 2. Which means if I graphed it, right? Which means if I graphed it, how many cycles would I see from 0 to 2 pi? 2 cycles. So if I saw 2 cycles from 0 to 2 pi, how big were each of them? 2 pi divided by 2. What if I made it a half? We didn't do that, did we? What if I made it a half? What if I made this a half? What is going to happen? How much do I see? Do I see a whole cycle? No, because a whole cycle of cosine goes down and then has to go back up, right? So how much do I see? Half of it, right? Shay, I only see half of it. If I want to see the other half, what do I need to do? I need to keep looking over there, right? How far more over do you think I need to go? Well, this goes from 0 to 2 pi. So I probably got to go from 2 pi to what? Another 2 pi. So how far out would that bring me? Out to 4 pi, right? There. Okay, so you're thinking going the other way. Yeah, I could go the other way. I'm glad that you said that. So I could look at more of my graph this way to see the cycle that what? Goes down and then comes back up. Or a cycle could what? Could go this way, right? And then come back over this way. But Aiden, if I did that, I'd have to go 2 pi that way, right? In which case it's still 4 pi to see a whole cycle, isn't it? Yeah. So guys, we could think about it that way. Frequency is a half, right? I only see half of a cycle. So how ready? If I take 2 pi and I divide it by a half, how many halves go into 2? How many halves go into 2? 4 do. So this means that it's going to take 4 pi to see a period. And a period is just one cycle. Guys, this can be extraordinarily confusing if you don't sort of envision these pictures that go along with it. Okay, the pictures will help you. Okay, so determine the period. Determine the period. How am I going to determine the period? Well, the first thing I need to do is figure out the frequency. And what is the frequency? 4. So the period is always going to be 2 pi divided by 4. Same as pi over 2. This is a little weird, isn't it? Pi over 3. All right, let's see if we can handle it. Based on what we've done, let's not change the game. What do you think the frequency is? Pi over 3. How do I find the period? I take 2 pi and I divide it by pi over 3. How do I clean this up? How do I clean this up? Anytime I have fractions within fractions, I should always think what? Keep, change, flip. Anytime I have a fraction within a fraction, I should always think keep, change, flip. So I'm going to keep 2 pi over 1, change division to multiplication, and flip this. So what does that give me? What's 2 pi times 3? 6 pi. What's 6 pi divided by pi? Just 6, yeah. Do you guys want to see like how cool that is right there? You don't even recognize how cool that is. We just changed the whole game right here. What did I just tell you here? I just told you that it takes how much to graph one cycle? It takes 6 to graph one cycle. 6 what? Bless you. We haven't done anything with 6, have we? But watch. But watch. So if I go 8 sine of pi, what was it, over 3 times x, and I want to change my window from 0 to 6, right? That said I should see one cycle in 6 units, correct? By the way, hey, what was the amplitude of that problem that I just typed in? 8, so I'm just going to make sure that I change this, and what am I going to see? How many cycles? One full cycle, right? Pretty cool. So that's a good way to check it, isn't it? Right? There's one cycle of sine. It fits perfectly, doesn't it? I didn't take attendance yet. All right, so I want to know the period of this one, right? Again, notice Jamie, do I care about this number in front, this negative 12? Does it have anything to do with the frequency or the period? No, all it does is just what? It affects the height, right? It's the difference from that. It's the difference, guys. I just want to make sure that you have this, right? It's nothing more than the difference from one of these to one of these, right? Changing the amplitude versus changing the frequency, okay? So the frequency is 2/3. The period is 2 pi divided by 2/3. So I have a fraction within a fraction, which means I'm going to do a keep change flip. Which gives me 6 pi over 2, which is now 3 pi. What? So now there's pi's back into the game, right? Which means if I wanted to look at this on the calculator, I'd have to go from 0 to 3 pi, wouldn't I? All right, so we can use that very literally to help us, can't we? So if I was to ask you to graph this without a calculator, what would we want to know? Well, the first thing is that the amplitude is 2. So when I graph this thing, I know I'm going to have an amplitude of 2, aren't I? Okay. What kind of curve is it? Well, it's a sine curve. What is the frequency? The frequency is 4, which means that the period is what? 2 pi over 4, which is the same as what? Pi over 2. Guys, what does that mean again? The period is the amount of space that is required to graph one cycle. Agreed? All right. So this is, I want to make sure it's clear, the space to graph one cycle. Now, what kind of a graph am I going to curve? What kind of curve am I going to graph? A sine curve, right? Where does sine start? At 0, at 1, or at -1? Well, if you're not sure, what can you do? Boom, boom, boom. That's 1, 0, right? Which of those is sine? The y value, right? So sine starts at 0, correct? All right. So if sine starts at 0, I'm going to have a point that starts right here, aren't I? What kind of curve am I graphing again? Sine curve, right? Okay, so let's go to 90. At 90, I'm at the point 0, 1, right? So where does my curve go? It goes from 0 to 1. But am I going to go to 1? No, what am I going to go to? What was the amplitude? 2, so I'm going to go to 2, right? And then where does my curve go from there? My sine curve does what? It goes up and then comes back down. So it's going to go here. Where do you think it's going to go next? Down to -2. Where do you think it's going to go next? Back to here, right? How many cycles is that? Hello, Mr. Schlesy. That's one cycle, right? That's one cycle. Okay. If I wanted to graph another one, I could, right? Do you guys agree that it would look like this? Yes? Okay. And here's the kicker. here's the kicker. Do I have the right amplitude on this? Yeah? Okay, ready? Aiden, you're gonna help me out here because I know you're gonna love this. How much space did it require to graph one cycle? Pi over 2. From here to here is one cycle, right? From here to here is one cycle, right? Do I now have a scale? Did I graph one cycle from 0 to pi over 2? I did, right? There you have it. There you have it. I knew you would. All right, we'll stop there, guys.